to Two Projects. In this video, we are going to explain about privacy-preserving location data publishing, a machine learning approach. Introduction. Publishing datasets plays an essential role in open data research and prompting the transparency of government agencies. However, such data publication might reveal users' private information. One of the most sensitive sources of the data is spatiotemporal trajectory datasets. Unfortunately, merely removing the unique identifiers cannot preserve the privacy of the users. Advisories may know parts of the trajectories or be able to link the published dataset to other sources for the purpose of user identification. Therefore, it is crucial to apply privacy-preserving techniques before the publication of spatiotemporal trajectory datasets. To overcome from this problem and to provide the security to the user location, many more data anonymization techniques such as k-anonymity and data perturbation was introduced initially, where data perturbation will add the noise to the user data and k-anonymity will adjust the data into groups so user location cannot be identified. But those techniques are not reliable as malicious users can identify how to crack the groups and noise data to know the user location. To overcome from this problem, machine learning based data privacy preserving techniques are proposed, which consist of 3 models, and 3 models will be provide more security and anonymize or generalize which cannot be easily understood or cracked. And they are clustering models include k-mean with SVD and PCA, dynamic sequence alignment with SVD and PCA, and data generalization. Dynamic sequence is called as heuristic clustering algorithm. Objective of the project is to address the privacy concerns associated with the publishing spatiotemporal trajectory datasets. The project aims to implement data anonymization techniques to protect users' private information while still allowing open data research and prompting government agency transparency. The existing techniques of k-anonymity and the data perturbation are deemed unreliable due to potential vulnerabilities to malicious attacks. To overcome these issues, the project proposes a novel approach based on machine learning models, specifically clustering algorithm, which are k-means with single value decomposition and principal component analysis. Similarly, dynamic sequence alignment with single value decomposition and principal component analysis. And the last one is data generalization. These models aim to provide enhanced security and anonymization by generalizing and anonymized data that is more difficult to identify, safeguarding users' location and sensitive information. Requirements for implementing the project are hardware requirements and the software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. We have used these algorithms in the project. First one is k-means. It is an unsupervised clustering algorithm that partitions the data into k clusters based on its similarity, making it useful for grouping similar data points. It is used to partition the trajectory data into clusters, allowing for the anonymization of similar trajectory sequence together to protect user privacy while preserving the overall patterns. Next one is k-means with PCA, which is principal component analysis. PCA is dimensionality reduction technique to the data before performing k-means clustering, improving efficiency and reducing noise. K-means with PCA is employed to preprocess the data and reduce its dimensionality, which can lead to better clustering results, more meaningful grouping, and improved privacy preservation. The next one is k-means with single value decomposition. SVD is a matrix factorization method to the data before conducting k-means clustering, enhancing the data representation and clustering accuracy. K-means with SVD is utilized to enhance the data representation by reducing noise and capturing the important latent features, leading to improved clustering and high privacy preservation. The next one is heuristic clustering. It is a dynamic sequence alignment algorithm that aligns the sequence based on similarity, allowing for pattern recognition and clustering of related data points. It is used to handle the spatiotemporal trajectory data which contains sequence by aligning and grouping similar sequence together for better anonymization and privacy preservation. The next one is heuristic clustering with PCA, which is principal component analysis. It combines the benefits of heuristic clustering with PCA, resulting in improved data representation and clustering efficiency. It leverages both the algorithms to enhance the data representation and reduce the noise. The next one is heuristic clustering with single value decomposition. It combines the advantages of heuristic clustering with single value decomposition, which enhances the data representation and clustering accuracy. It is employed to improve the data representation by reducing the noise and capture essential latent features in the trajectory sequence and resulting it in more clustering and better privacy preservation. These are the modules for the execution of the project. In the first module, which is upload taxi trajectory dataset, here we will be uploading the dataset. The next one is pre-process the dataset. The data contains null values, so we need to remove it. Then the location is extracted. The next one is run k-means with dynamic assay algorithm. In this, we will be implementing the k-means algorithm and dynamic assay algorithm with the dataset. Similarly, we will do in the modules which are k-means with PCA and k-means with SVD. The last one is data generalization algorithm. In this, we will be generalizing the data. The last one, which is loss comparison graph. In this, we will be comparing the loss of all the algorithms. Execution. For execution of the project, first open the code folder. So this is the code folder and this is the data set. Using this data set, we will be executing the project. And this is the main file which contains the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we have created the Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. This is created by using Tkinter library in Python. So first we need to upload the taxi trajectory dataset. For this, click on this button. Select the data and click on open. Here the dataset is uploaded. Now click on the button preprocess dataset to preprocess the data for remove the null values. Here the dataset is preprocessed. Now we need to click on the button run k-means with dynamic sequence algorithm. Here for every location, the loss is being calculated. Here, the k-means algorithm's loss is this much and heuristic loss is this much. Heuristic is nothing but dynamic sequence algorithm. The next one, we need to run on the button k-means with PCA algorithm. Here is also for every location loss is being calculated. This is the average loss of PCA with k-means algorithm and PCA with heuristic algorithm. And now we will be running k-means with SVD algorithm. For this algorithm also, for each individual location, the loss is being calculated. Here, it has averaged the SVD k-means loss and SVD heuristic loss. Now, we will be generalizing the data. For this, click on the button Data Generalization. Here the data is generalized. Now, click on the button Loss Comparison Graph to compare the loss of all the algorithms. Here on the x-axis, the algorithm names are represented and on the y-axis, algorithm scores are represented. Now, among all the algorithms, PCA heuristic loss and SVD heuristic loss is very less. Conclusion. The conclusion of the project is that the dynamic sequence alignment referred to as the heuristic clustering algorithm along with PCA and SVD with the heuristic algorithm achieved the lowest loss among all the algorithms tested. These findings indicate that the combination of dynamic sequence alignment with PCA and SVD using the heuristic clustering algorithm resulted in the most effective data anonymization and privacy preserving technique for spatiotemporal trajectory dataset. The lower loss signifies better performance in safeguarding users' private information and location, making this approach the preferred choice for anonymizing and protecting sensitive data while allowing for open data research and transparency of government agencies. The success of these techniques highlight the importance of using machine learning based approaches to enhance the data privacy and security in the context of trajectory dataset. Thank you for watching this video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.